Hello, geometry students. Mr. Zacek back here with you in Unit 4, Lesson 2-2. This one's going to go a little bit quicker than the last one, but both of these go together here with your next assignment. And we're going to prove triangles congruent by side, side, side. So just a quick review. In Lesson 4-1, we said that congruent means that all their corresponding parts are congruent. And so we're building out the methods which we can prove that triangles are congruent. So the first method we talked about in our last lesson was side, angle, side. And the method that we're going to look at today is called the side, side, side postulate. And it says if three sides of one triangle are congruent to three sides of another triangle, then the two triangles are congruent. So we've got a picture here. If AB is congruent to DE, BC is congruent to EF, and AC is congruent to DF, then the triangles are congruent. And the reason that we would put is that side, side, side is congruent to side, side, side. All right, so let's go through now, and what we want to do, kind of our process is, we want to start by mark the givens on the diagram. So we've got LM congruent to NP, and we've got LP congruent to NM. All right, and so after we mark the given, we're going to look for our freebies. And in this case, both of these triangles share this common side Ln, and so that's the reflexive property. And just to remember that freebies are, we're looking for reflexive property, that's shared sides or angles, and we're looking for vertical angles. Those would be the things we'd look for in the reflexive property. Potentially a linear pair would be another freebie. Okay, and then so from there, let's make a plan. And the plan for this one is going to be that we have all three sides. So we want to use side, side, side congruent to side, side, side. That's our plan. Okay, so let's go ahead and execute that plan. I'm going to start off with our givens. LM is congruent to NP, and LP is congruent to NM. And what have we accomplished? Well, it's first the given. What have we accomplished with that? Well, we've already got a side congruent to a side and a side congruent to a side. So we've got kind of 2/3 of our plan taken care of. And so we need to get our third side. And the way that we get the third side is with the reflexive property. So we say Ln is congruent to Ln. Remember, when we're doing reflexive property, we want to think like you're looking in a mirror. Reflexive property. So it should always be the same thing on both sides. And that was a side congruent to a side. So we've got statements that have all three sides congruent. And so therefore, we can say that triangle LMN is congruent to triangle NPL. And the reason is side, 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 congruent to side, side, side. Okay, so real, pretty basic, just givens and a freebie. We didn't need any kind of our proof parts one. We will in this one. So let's start off and mark our givens. So we've got, this is C up here. I don't know if that printed on yours or not, but CB is congruent to CD, and then it says CF bisects BD. So this is the one that's going to cut. So CF is going to cut BD into two congruent parts. All right, those are our givens. And then our freebie, they have a common side by the reflexive property. So our plan, therefore, would be side, 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 congruent to side, side, side. So mark your givens, get your freebies, come up with a plan, execute the plan. So step one, let's bring in the givens here. CB is congruent to CD. All right, CF bisects segment BD. Okay, given. So what part of the plan have we accomplished with that? Well, we've got a side congruent to a side. We've got 1 out of the 3. But we've also got CF bisects BD, so that gets us another side. We can say BF is congruent to FD, and if you have your proof terminology sheet that you're looking at, you want to look at the segment bisector section, and you can write this out. It says, if a segment bisects a segment, then it divides the segment into 2 congruent segments. So again, this is right off that proof terminology sheet. If a segment bisects a segment, then it divides a segment into 2 congruent segments. There's a lot of the word segment in that reason. It can be a little tricky, a little wordy. So we've accomplished another side congruent to another side, all right? And then we've got to get our third side, all right? We haven't executed all of our plan yet. So that was what's our third side? Well, that's up here. CF is congruent to CF. And why do we know that? We know that because of the reflexive property. Okay, and so that is also a side congruent to a side. And so now we've got 3 congruent statements about the side. So we can say now that triangle BCF is congruent to triangle DCF, and the reason for that is that we have side, side, side congruent to side, side, side. Okay, so you have a nice little reflection question, but let's just review now the methods that we have for proving triangles congruent that you're going to use in your homework assignment, or your class assignment. There is, we've got side angle side, and we've got side, side, side. So we need to determine which one. We've got 2 different plans that we can utilize for this. All right, so good luck on that assignment. Ask, keep on asking, and then when you're working on these, make sure that you get that proof terminology sheet out. That's going to really help you a lot. All right, talk to you soon.